Right, in this video, we're going to take a look at an application of some of the concepts we've talked about in this section already. So we're going to look at the velocity of a particle along a horizontal axis. So velocity of an object measures the object's speed along with the direction that the object is traveling. So if you're in a car and you look at the speedometer, that'll tell you the speed, how fast it's going, the car is going. And if you look at what direction you're heading, that speed with that direction is velocity. So in this example, we're going to look at particles traveling along a horizontal axis, like the x-axis or something where it's just one-dimensional. So if our velocity is 0, then the particle is at rest. So it's not going to be moving if its speed is 0. If the velocity is positive, so if we graph our function and the velocity is positive, which means it's above the x-axis, the particle is moving to the right. And if it's negative, in other words, the graph of the velocity function is below the x-axis, that means the particle is going to be moving to the left. So if we look at example 5, the velocity of a particle moving along the x-axis at any time greater than 0, t greater than 0, is given by v of t equals 2t to the third plus 7t squared minus 53t minus 28. So we're going to want to graph this in our graphing calculator, or I'm going to use Desmos. So let's take a look at that. Okay, so we're going to take a look at our particle motion example. So we have the velocity of a particle at any time t greater than 0 is given by 2t to the third plus 7t squared minus 53t minus 28. And here I adjusted the window, the viewing window on Desmos. The default is negative 10 to 10 for the x and the y. And so for this one, if you want a better view of the graph, just click on the graph settings option. And here I have the x-axis between negative 20 and 20. And I have the y-axis between negative 500 and positive 500. And here I've locked the viewpoint so that way I can't accidentally zoom in or zoom out. This isn't necessary. It's just a way for me not to mess up the appearance of the graph as it is. So for our first part, we want to know where the particle is moving to the right. And for our velocity function for the particle, it's moving to the right when it's above the x-axis. Now notice this as it is, it's going to graph the entire thing where the domain of this function is all real numbers. But if we want to limit it to where t is only greater than 0, then after this function we can type in curly braces or t greater than 0. And it'll restrict the domain and only graph values that are greater than 0. So looking at our graph now, with that condition that t has to be greater than 0, notice our graph is above the x-axis. Its particle is going to be moving to the right for values beyond t equals 4. So for more than 4 seconds, or whatever the time unit is, our particle will be moving to the right after t equals 4. Okay, so now we want to know when the particle is moving to the right. And as we saw from the graph, it's moving to the right for values of t that are greater than 4. So in interval notation, greater than 4, parenthesis 4, comma, infinity, parenthesis. Next up, when is the particle at rest? So it's going to hit the x-axis at t equals 4. And we saw from the graph that the particle is at rest at t equals 4. Finally, when is the particle moving to the left? Is moving to the left, or the particle is moving to the left rather, when the graph is below the x-axis. And here we have the graph below the x-axis for values of t that are greater than 0 but less than 4. And the graph that we saw was moving to the left when t was between 0 and 4, so parenthesis 0, comma 4, parenthesis.